4 times 3 times minus 4. Will you calculate that for us, please?
Yes. Okay. So -4 times 3, -12 times -4, positive 48. And then, so that's going to be 4 minus 48. Yeah.
It'll be plus because this one ends up being negative 48.
Plus 48, which would be 52.
Good, very good. And that's where most of the mistakes are made. So this becomes -2 plus or minus the square root of 52 all over 6, like that.
I sometimes always get my negatives and positives mixed up. It's annoying on my part.
Yeah.
I know what I'm doing.
There's a couple ways to look at it. One is to treat it like it's -4, multiplying each of these, or to wait until the end to deal with it. You'll get some more practice on this. Now, the square root of 52 is a prime factorization. So you start with 2. 2 is the smallest prime number. 2 times 26 gets you back to 52. And then you try 2 again, 2 and 13. And you stop when you have prime numbers on the edges out here. And 13 is a prime number. And if you recall, you're looking for pairs. So because there's a pair of 2s, you're going to bring a 2 out. But you leave the 13 in. So the square root of 52 becomes 2 square root of 13. Is that okay?
Yeah, that works.
Okay.
Yeah.
And that's something they expect you to be able to do here. So -2 plus or minus 2 square root 13 divided by 6. You remember from yesterday what we do at this point here?
I think so.
Can you tell me verbally before you go ahead and try it?
I believe that we made them into 2 separate types of fractions with plus or minus.
Exactly. Yeah.
Yeah.
And then it's only the number outside that can be divided by the denominator. It's never what's inside. That's sort of protected. So this becomes
like square roots.
Yes. And this becomes square root of 13 divided by 6, or you could put like a 1/6 in front. And then most of the time, the answers are presented separately. -1/3 plus square root of 13 divided by 6, -1/3 minus the square root of 13 divided by 6, like that.
All right, I got it.
Any questions on that?
No, I got it. I understood it.
Okay. So before we do the next problem here, just give you like a quick, I don't know what to call it, a quick lesson. All right. So these 2 graphs on the left here are going to have 2 solutions. Okay. So here's one. Here's another. Okay. Why do you think they have 2 solutions?
Well, I'm not sure because.
Okay. So let me lead you through that here. How many times does this U-shaped cross the x-axis?
Only once.
What about over here?
Oh, sorry, twice.
Twice. And then same question here. How many times does this U-shaped graph cross the x-axis?
Twice, right?
Twice. So the 2 solutions, you can think of solutions as number of times that it crosses the x-axis. Okay. Now we're going to come over here to the right, and we're going to talk about 0 solutions, what that might look like. So 0 solutions, here's your first graph. Here is your second graph. How many times do these graphs on the right cross the x-axis?
None.
None. So that's why it's no solution. So then it raised the question, well, what would one solution look like? And it's one solution if it touches. So you can think of it as touching or bouncing off, something like that, but it touches there.
Oh, okay.
Okay. So that will lead us to be able to answer question 8 here, this information. It's like your reference sheet for this problem here. So let me get the, all right, so All right, so here we go. This is, multiple choice. Usually students think of 4 answers. There could be as many as you want. You're looking for the answers that coincide with touching. So that is, if you go back to our graph here, that's
one solution.
one solution. So it's either A or D.
All right.
Which one is it?
Well, it's A because where the curve is happening, well, where it's the both of the lines are starting to curve up, it's where it's 1.
Yes, it's where it touches that, where
Right.
that point where it touches is 1 right there.
Mhm.
Now, interestingly, the y value there is 0. If you think of that as an ordered pair there, it's 1, 0, but it's the x value that we're interested in for the solution.
Right. These types of problems were so confusing when I was younger. Now they make more sense.
All right, so you have enough information here to try and answer number 9. So I'm going to snip that in, and we'll see. Take 60 seconds here.
All right.
It's not a race. It's not a timed event. Do the best you can, though.
Well, this time it's not bouncing, so that means it's 2 solutions this time.
I agree.
Yeah. So that means, okay. So when it comes to crossing out the multiple choice, I would say we could remove A because it talks about 1. We can remove B because we're not talking about complex solutions. The same thing with D and hmm. And then I would say F.
So are you saying to remove F, or it is F?
No, remove F.
Remove F. Okay. All right.
So now I have 2 options. Now I'm looking at the graph. I would say remove B as well. So which would lead the answer to be E because both of the points are at -1 and at 1.
That's right.
Yeah.
Very good. All right. Any questions on that, or thoughts or concerns?
No.
All right. Okay, so we're up to 10 here. Number 10, this is what did they call it in your thing here? Apply your knowledge. All right. Basketball player shoots a free throw that ends up being in the air, completely falls short of the basket, and the ball's height off the ground can be modeled by the equation y equals -3x squared plus 12x plus 4, where x is the number of seconds that have passed since the ball left the player's hand. How long will it take for the ball to hit the floor? Okay, so here is the graph of this thing. Very, very rough sketch here.
All right.
And in these application problems, they're either asking you about this place up here at the top or this place down here at the bottom.
Right.
Will you read this one more time? And I'll help to highlight where you should focus your attention, but you want to determine whether we're interested in 1 or 2 in this problem.
Okay, so a basketball player shoots a free throw that ends up being an air ball and completely falls short of the basket. And the ball's height of the ground can be modeled by the quadratic function y equals -3x squared plus 12x plus 4, where x is the number of seconds that have passed since the ball's left the player's hands. How long will it take for the ball to hit the floor? So we're looking at number 1, basically, from the graph that you have drawn.
So we're actually looking here at number 2. Think of now I'll add a little bit more. Now I'm not very good, but think of this as the player.
Okay.
And here is, and I'm not sure if I know you're not a basketball player from what I understand. There's the hoop. Okay. And so 2 is where it hits the floor again, or the ground.
Okay.
So the reason I asked you this is the hardest part, is figuring out, well, what am I supposed to be figuring out here? Is it the vertex of the graph, which is up here at 1, or is it where it hits the ground, or basically where it's equal to 0? So the short answer is that we are setting this equation, y equals minus 3x squared plus 12x plus 4. We're setting it equal to 0.
Okay.
And that's because at the floor, y equals 0 on the floor.
Mm-hmm.
So this is a very complicated way of asking you to solve this quadratic equation using the quadratic formula. Is that clear?
Yeah.
Okay. Now we're going to set it up, but this time we're going to use the calculator because it says to round your
To the
final
nearest.
answer nearest 100. So that gives us permission to use the calculator here.
Okay.
Have you used, what kind of calculator do you have available to you?
Just the generic Apple calculator.
Okay, I'm gonna suggest, and drop this in the chat here, I'm gonna suggest using maybe this one today, the Desmos Scientific. I can even
Okay.
show you how to use it if needed here. It's very intuitive though. We know that x equals minus b
Okay.
plus or minus the square root of b squared, so 12 squared, minus 4 times minus 3 times 4, all over 2 times minus 3.
Mm-hmm.
Now, the reason I'm suggesting to use this other calculator here is, and I'm not sure if you want to do that right now. I can show you in another window here how to use it, but you actually enter it exactly the way it's written, which is really nice.
Yeah.
What would you like us to do? Do you want to try calculating this on your own? Do you want me to show you how to do it? What would be
Can you
best?
tell me? Because I've never used the Desmos calculator.
Got it. All right, so I'm going to really quickly share my screen, this other screen here, and let's let that load up. There it is. Okay, so it's that link I sent you, Desmos Scientific. I'm not affiliated with them. They do make a nice product though. So x equals, and now the first thing I'm going to do is put a fraction bar in here, which is the division symbol, and I'm
Okay.
just going to enter it exactly the way that it's written there. So instead of plus minus, that I will choose plus, square root 12, and then you can square that, minus 4 times minus 3 times 4, like that, all over 2 times negative 3.
Mm-hmm. Oh my God, Desmos is so confusing.
You don't like it? Okay.
It's not my thing. It was the same way when I had to learn how to graph on Desmos. I got so confused with
Okay. So there is another way to do it. I mean, but you have to sort of, you're the math student. You have to sort of say, okay, this is how I'm going to do it. Now, one of the nice things about Desmos, they got copy and paste, and I can just change this to a minus to get the other one.
Mm-hmm.
And that is, the second one is the one that we want. Okay, and we'll talk about why in a moment here. But let me show you, well, we'll see if we need to. Yeah, so you're going to need a calculator in this course. Doesn't matter to me what you use. I'll probably continue to suggest using this one and help you with it along the way. But let's go back to the other screen here and take a look here. So, all right, there you go. So we have two answers. And it's like, well, how do we know which one, or why would one be correct versus another? If we go back and look at our drawing here, the time here is positive. Time propelled forward. So why are there two answers? Well, the reason there's two answers is because the quadratic itself has two solutions. It's got one there and one there at each of those arrows. But physically, the physical problem, we only care about the one to the right.
Right.
So this is the answer that we're looking for here. They do say to round to the nearest hundredth. Okay.
Yeah.
So that would be, I think, and just double check that, that's 4.31. And then you want to give it in time, seconds. I don't know, it seems like a long time for a ball to be in the air, but maybe that is about right.
Really good throw.
Yeah.
Yeah. Also, time can't be negative.
That's true. So that's another way to sort of gauge which one is reasonable or not. Because you don't really have any way to know. You don't have a sense of like, oh yeah, like it's going to be 4 seconds or 5 seconds or 3 seconds. You really don't know. I mean, we don't have a good sense of that, unless you're an expert.
Mhm.
Now I understand that you do some ice skating. Is that right?
Oh yeah, I'm a figure skater.
Figure skater.
Yeah, I've been skating for 2 years.
So like you probably do some jumps where you get in the air. Was that true?
Yes.
And you probably know you're in the air for how many seconds?
I don't know. It just depends
Okay.
on what they're rotating for.
Okay.
I assume maybe, in my estimation, I'm maybe in there for like at least maybe half a second,
Okay.
unless.
And see, I wouldn't know. I wouldn't know whether it was 1 second or 2 second. So sometimes these problems, we just don't know what's reasonable. So you got to really double check that your calculations are correct.
Right.
All right. So that takes care of that assignment here. Looks like we're on to
It's less.
the next one. There it is. Okay. So number 1, stop and think. Okay. We're going to stop and think. Here we go. In the projectile equation, h of t equals minus 16t squared plus 12.3t plus 4.9, what number indicates gravity in feet per second squared? Okay. This is beyond the scope of this course, in my opinion. But the projectile equation, which you will see in physics if you take physics, is 1/2 at squared. Oops, that's all wrong. 1/2 at squared plus vt plus what's called h. And this is a simplification. There's some other equations here for it. The acceleration is the acceleration due to gravity in this problem. So what they're trying to tell you here is that the minus 16 is the part that refers to gravity, but that's kind of not correct. The gravity in US units is 32 feet per second squared.
Mhm.
And this equation that governs this from Newton's laws, you end up cutting it in half. And then why is it negative? Because everything that goes up must come down. So we assign negative to be down.
Yeah.
So I'm probably giving you way too much information there, but they're probably looking for the negative 16, but know that it's really 32 and you're cutting it in half and you're negating it because it's gravity goes down.
Mhm. Newton is very interesting. He's fascinating to learn about.
Yeah, we attribute a lot of calculus and physics to him.
I mean, he did make calculus, so yeah. Math.
Yes.
Yes. Very
All right.
lovely.
All right. Is that enough? Sometimes I don't know. You have to tell me, hey, Matthew, like that's enough, or I need more information. Do you feel like that satisfies
A
this
little bit
question?
more explanation because this is something new, and yeah.
Is that okay? We can move on.
Yeah.
All right.
Gravity, man.
That's gravity. All right. So same thing here, except it's asking about the height of the object. So it's
Mhm.
trying to indicate that here the height is h, and that's 4.9 in this problem.
Mhm.
So that means it started 4.9 feet above the ground. Your explanation for that, because this function up here, h of t, is a function of time, when you put 0 in for t, let me just get this right, it's minus 16, 0 squared, plus 12.3 times 0 plus 4.9. So when it's launched, the time is 0. That causes these terms to go away. 0 squared is 0, minus 16 times 0 is 0. 0 times 12.3 is 0, 0 plus 0 is 0. You're just left with 4.9 feet.
Hmm. Really? That did not. So basically, it's just going to be the same answer as it was last time. That's
No. The previous one is minus 16.
oh
Maybe
yeah.
that was unclear. Sorry. The previous answer is minus 16 to number 1.
Mhm.
For number 2, the height is this constant value, which is 4.9, but I was showing you how you can calculate it.
That's cool.
All right. Does the object hit the ground? All right. So I'm looking at 3 and 4.
Mhm.
They appear to refer to something that we don't possibly have.
Like as an object or
It says here in example 2 above, when does the object hit the ground? In example 3 above, when does the object hit the ground? And I take that to mean there's an example in like kind of in the lead up to this.
yeah, I can check right now, maybe send it to you.
Okay.
Yeah, let me just find. Okay. So example 2 and 3.
Yes, looks like we need example 2 and 3. I'll just scan through the rest to see if there's any others we might need.
Also believe there you might have one of the login information, so you can also
Yeah. Yeah, I can log it. It'll take me a minute or two to get that, but I see that we also need example 6.
Yeah.
So
Well,
do you want me to log, excuse me, do you want me to log in or do you want to send over?
you can log in because it's going to be easier because
Okay.
I'm right now looking. I did not see this object. All I
All
know.
right. All right, let me get to where I can do that.
It's lesson 13, by the way. That's
Great. More schools. All right, and then the login. All right, I am getting close here.
if you help, let me know because it's a little bit confusing all over the place just to look for a lesson.
Yeah, I'm almost there. It's more about I just got to get the right things up here. 082021. Okay. All right, that should do it. I was able to log in yesterday, but we didn't end up needing it. But then, of course,
Yeah.
computer restarted and I'm not there anymore. All right. There it is, Algebra 2. And you said lesson 13.
Yep.
Lesson 13, which of course I can't see. So I will share my screen so you can tell me where that is. All right.
Don't worry, I will tell you.
All right, so you're seeing my screen now? Yeah, there you go.
Go to the full course lessons. That's where you can see everything. It's on, yep, right.
Okay,
And then it shows you all the different types of lessons.
I got it.
So the next time when you log in, now you know where to look.
Got it. Okay, now we're just looking for example 2.
Yeah.
Ah, here it is. Okay. All right, so that's enough there to get us. All right, so let me go back to the other screen. All right, so this is kind of a loaded question now. There's several things to do to actually be able to answer it, but we can do that according to this. Okay, so example 2, an object is launched directly upward at 64 feet per second. So I just want to quickly show you how they are coming up with the equation. The equation is h of t equals minus 1/2 a t squared plus vt plus h. This is v, the 64 feet per second. This is h, and then a is known to be 32. So this becomes minus 16t squared, because 1/2 of 32 is 16, plus 64t plus 80. Okay, and that's actually given for you, but I wanted you to see at least one of them
Yeah.
set up here. Okay, so now we got to figure out, when does the object hit the ground? Okay, so you're setting the equation equal to 0.
Right.
Now this one, believe it or not, appears to be factorable. So we don't need to use the quadratic formula unless it's said to use the quadratic formula.
I don't think I can.
It does not, just says show your work. Okay.
Yeah, just show your work. So
this is t squared minus 4t minus 5 equals 0. And now you're looking for two numbers that multiply to minus 5 but add to minus 4. Can you tell me those numbers? Multiply to minus 5 but add to minus 4.
multiply to minus 5. Oh, it's gonna be like 1 times 5.
So if it was 5, 1 and 5 are correct. We want minus 5. That means one of them has to be negative, either negative 1 and 5 or 1 and negative 5.
Well, it would be I would say the 1.
We want to add up to negative 4, and that is the second one. So we got t plus 1, t minus 5, like that. Okay. And do you remember what to do from here to solve this?
I was about to say FOIL, but
So FOIL will get us going backwards.
yeah.
So we want to set each of these equal to 0.
Oh yeah.
Okay. So this first one, you subtract 1, so t is minus 1. The second one, you're going to add 5, so t is 5. Which one makes sense in this situation?
The 5.
Yes, so you'd say 5 seconds later.
Because positive time.
Positive time, yes.
Also,
All right.
if it was negative time, wouldn't that mean you're going back in time, basically?
Sure, and there are scenarios where where that actually is something you might have, but not in your class. You're never going to see that in your class. So
It's a good question, I would say.
yeah, students will often ask me things like that. They'll say, hey, are there any exceptions to this? And I'm like, nope, you never have to worry about negative time in the scenario. Okay, so example 2, we just did 2. Next one there. All right, so here we go. And example 3, when does the object hit the ground? This is the equation from example 3.
Right.
All right, so we're skipping the part where we explain why this is, we're just going with it. It hits the ground, that means you're setting it equal to what value?
0.
0, okay. Now this time, there's a t in both equations. Okay, and that means you can factor a t out for sure.
Yeah, well, we just have to take out 1 t.
That's right, but we might be able to take out the number here, this minus 4.9. So I'm going to check that real quick before I say for sure.
You have a dog?
I apologize. It's not my dog, just dog sitting for the moment.
Oh no, it's okay. I have a dog too.
Nice. What's your dog's name?
Hermes.
Hermes, cool.
I'm a mythology nerd.
Cool. So this one, you can actually factor out both a minus 4.9 and a t from both. And here's what that means. You're actually dividing both of these by minus 4.9 t. So when you're taking out what's called the GCF, which is what we did here, you have to divide each of these by the GCF. Now the one on the left, the minus 4.9, the minus 4.9, they cancel. So you got t squared over t, that becomes just t.
Okay.
Can you go to any calculator you want and divide 39.2 by minus 4.9?
Yes. I'm doing that right now. 0.2 divided by like 8.
Yes, so this becomes minus 8. What is t divided by t?
wouldn't it t divided by t, wouldn't that still be t?
So let me ask you differently. What is 3 divided by 3?
Oh, that's 1.
And it's 1 because it's the same on the top and the bottom. So t divided by t is also equal to 1 because it's the same on the top and the bottom.
Oh yeah, because I forgot. Like if there's no numbers on the t, it's always 1.
Yes, very good. All right, so now, just like in the last problem, we're going to set each of the factors here. And the factors, like this is a factor and this is a factor, we're going to set them equal to 0.
Mm-hmm.
All right, so let's solve the one on the left first. How do you undo this number in front of t?
You divide.
You divide both sides by minus 4.9. What is 0 divided by anything besides 0?
0 divided by anything besides 0, it's still going to be 0. So
Very good. And what's the answer to the other one here?
the 8.
8. So that's the one we want. 8 seconds later. Any questions on that?
Nope, I got it.
Got it.
Yeah.
All right, so let's take a look at question 5.
And that, I hope I copied and pasted pretty well. Well,
Yeah,
not how to put it on the screenshot, I'm sorry.
we'll go to the, we'll grab some from the book now if needed. I just didn't want to be wasting your time yesterday with me logging in and things like that, but
Oh no, it's okay.
we got it here. So it says, solve the following problems. These are application problems. So we have to translate this sentence into an equation. All right, so it says 4 times the sum of 3 consecutive odd integers is, that's a breakpoint, 765 less than 3 times the product of the 2 larger numbers. What are the 2 sets of 3 integers? Okay, there's a lot here. We're going to let x be the smallest odd integer. Like we don't know the value of it, but that's going to be the smallest odd integer. Okay. And let's just say, for example, and I have no idea what the solution is, but let's just say, for example, the answer is 77. Okay. What is the next odd integer after 77?
Like the next odd integer?
Yes.
79?
79. How do you go from 77 to 79?
Well, you add by 2.
So x plus 2 is the middle.
Right.
The middle integer. Now the next one is 81, but you're going to go from 77. How do you go from 77 to 81? What do you add in this case?
77 to 80. You add 4.
Yes. Okay, so there you might think that there are 3 variables, but it's actually 1 variable, and you're just adding 2 to it and then adding 4 to it.
Uh-huh.
All right. Now we can go and translate this part into something. So let's do it in pieces here. 4 times the sum of 3 consecutive odd integers. What math operation is times?
I actually do not remember.
Okay, it's multiplication. So we're saying 4 times. What math operation is sum?
That's adding.
Okay, adding the 3 consecutive integers, x plus 2 plus x plus 4. So let's read it one more time. 4 times the sum of
X plus 2, and then x plus 4.
Okay. Now the word is always means equal.
Yeah.
765 less than, okay. So less than means subtract 3 times the product of the 2 larger numbers. Okay, so the 2 larger numbers are x plus 2 and x plus 4. We want 3 times that, and then we subtract 765. So in the English language is not the best language, but in the math world, whenever you see a number less than, it means that you're going to do it at the end.
Right.
So it's awkward because it's like, why doesn't it just say is 3 times the product of the larger two numbers, subtract 765? I don't know. That's just the way that this thing is made.
The math language is the hardest language to master sometimes.
Right. So what I'm going to do real quick here before we go much further is just check that this actually has the solution that I think it has. Otherwise, we're going to waste a lot of time proceeding forward. So occasionally I'll just go to another screen here and I'll either graph it or I don't know, I'll just do something to make this make sense. And this does have a solution, so a good one for us. Okay, so this is a pretty challenging problem from here. Any idea how you might start something like this?
To be honest, no.
Okay, so we're going to start inside parentheses here, and we're going to combine like terms.
Right.
So it's 3x plus 6, okay? And then we're going to multiply it by 4 now. So 12x plus 24 equals.
Mhm.
Now on the right here, you mentioned this earlier, FOIL.
Oh yeah, I did, didn't I?
Do you have any idea how to FOIL this?
Well, for starters, this is what someone taught me. It's innies. It's like no outies, innies lasties, basically.
Okay,
Okay.
let's start with the letters here. F stands for the first times the first, x times x. And what is x times x? Can you tell me that?
That would be x squared.
Squared. O refers to the outside or outer, and that's the x times the 4.
Yeah, that's why I call them outies.
Outies, yep. And then I stands for inside or inner, or I guess innies, 2 times x.
Yep.
So that's 2x. And then L stands for last,
Mhm.
2 times 4, which is 8. So this is x squared plus 6x plus 8. You can almost always combine the O and the I when you're
Mhm.
doing this. Now we have neglected, I'm going to draw it here, we've neglected to bring the 3 down and the minus 765 down. So we need to do that as well.
I was about to say, like, why are we not dragging them down?
Yeah, and sometimes in math, you got to go off and do a little piece of a problem, and you got to come back and do the rest.
Yeah.
All right, so now we are going to distribute this 3 to everything. So this is 3x squared plus 18x plus 24 minus 765, 12x plus 24. Okay. So we should move everything now to one side of the equation. Let me know when you get caught up here. I don't want to keep going through this until you're at the same step.
All right, I am now at the same step. I just
Fantastic. So we're going to subtract 24 from both sides.
okay.
And we're going to subtract 12x from both sides. And notice I'm writing it under the one that it combines with.
Yeah.
So this becomes 3x squared plus 6x minus 765. And just because of the preference, we like it to equal 0 on the right, generally.
Okay.
I mentioned this earlier. Do you remember the first type of factoring that we generally like to apply here?
I think that you said was multiplying, but
So we're looking for a GCF.
oh, greatest common factor. Yeah.
Yes. Is there a GCF in this?
Well, the can I say 765?
So here, so you can use, yeah, you can use a calculator, or the shortcut is to add the digits 7 plus 6 plus 5, which is 18. If the digits add up to a multiple of 3, then you're good. So this one actually does work.
Oh, yeah.
Each of them are divisible by this. 253 equals 0. Sorry, the 55. Okay. So now you're looking for two numbers that multiply to minus 255, but add to positive 2. And this would take a while to sort of guess and check. So I will give you those numbers. It's positive 17 and negative 15.
Mm-hmm.
Do you remember what we do from here to solve for x?
I think so.
We did this in a previous problem. If you need to look, if you want me to scroll up or look back in your notes.
Can you scroll up for me, please?
Yeah, so what we're doing is what we did in kind of this step here, down to this step.
Okay. Oh, you with the two separate problems with the t minus like the book.
Yes. So you're gonna do the same thing here. You're gonna set each of those equal to 0. What are the two answers in this case?
X minus x equals negative 17 and x equals 15. And we want the positive one, which would be 15.
Well, if we go back and look at the answer here, it says, what are the two sets of 3 integers? So there's actually 2 answers.
So this time it would be both of the x's.
It's a start. So let's start with x equals 15. That's the smallest number, odd number. And then you've got to add 2 to it.
Oh, so like,
And then you've got to add 2 more. So this is your first set.
okay. So like x equals 15, 17, 19, and the other one.
So this one's negative 17, but you have to add 2 to it, which actually means it goes the other direction.
Goes down, basically.
Let me think about that.
Math is confusing sometimes.
Okay. All right. So any questions on that or any follow-up? Those are pretty challenging question there.
No, I think I got that understood after you told me.
Great.
About
So
the thing.
Yeah, these are all application problems. They're all going to be a little bit tougher here. So here we go.
The more I do them, the more I'm going to understand them. So yeah.
Exactly. I like the way you said that. All right, number 6 here, it says a ball is launched upward at a speed of 20 meters per second from a 60-meter tall platform. The equation for the ball's height in meters at time t is given by this equation. Here we go. That's what we want. What is
platform?
I'm sorry?
How tall what is a 60-meter platform?
So you can think of it as like, I would think maybe a pool. Well, no, that's not true. A platform is just something up above, and like I think of a diving board, maybe that could be considered a platform.
Oh, that's high.
Yes, yeah, it is. I'm not getting up there. So
Why?
it says, what is the height above the ground when the ball is launched? So I actually kind of didn't give you the full information here. There's actually 3 places that you're interested in sometimes. So the first one is over here on the left, the max height, and then down here at the bottom. We are interested this time in number 1.
Okay.
Okay, so when it's launched, t is equal to 0.
Mm-hmm.
Okay, so we're putting 0 into that equation. Minus 4.9 times 0 squared plus 20 times 0 plus 60. What would that be?
That says, sorry, I can't read the second thing that you wrote in hand.
Is it too small, or is it not written well?
No, it's just like the second, like after the negative 4.90 squared. I don't know what number that is. Is it 20?
20. Yeah, 20.
Thank
Yeah,
you. I thought it looked like a 70 to me, and I was like, that's not right, is it?
Yeah, 20 times 0 plus 60.
So basically, if that was all 0, like, and you multiplied negative 4.9 with and 20 with 0, that's 0. So h in parentheses zeros would equal just 60.
Yes.
Yes.
And is that consistent with what we read here, that it starts from a 60-meter tall platform?
Yes.
It is, and that's what we were expecting here. All right. Did you get all that down for? Okay, so number 7 here, running a little short on time here. The lessons are 50 minutes long.
Yeah.
This is actually this one. The application problems take a lot longer than they should. Maybe we'll be able to go a little faster in other lessons, but same situation here. Okay, this time we're looking for where it hits the ground. We care about this place right there. What's the height when it hits the ground?
Um, I do not. Well, it says right 0.
0, 0. So when you're on the ground, your height is 0.
Mhm.
Okay, so we're going to set this equation equal to 0. Okay. How might you solve something like this?
Like the way we did last problem, but like, wait, no, we multiplied it by 0.
This one doesn't factor well, unfortunately.
Yeah.
So when it doesn't factor well, what's the backup plan? What always works?
I was about to say multiplying.
What did we do yesterday?
Quadratic.
Quadratic formula. Yeah.
Oh
So
dear, here it comes.
yeah, so we actually don't have time today. We're basically at the end of our lesson here, but if you want, you can try this one out and see if you can get it. Happy to continue on this one, next time. I know we got a lesson on Thursday
Yeah.
at I believe it's 2 o'clock. So that is going to do it for us today. I'm going to go ahead and stop the recording right here.